All right, the next one we're going to look at Unit 3, Charles' Law. So Charles' Law, we have this equation, V1 T2 equals V2 T1. So we'll put that up here, V1 T2 equals V2 T1. All right, so for our problem here, all of these we need to change to Kelvin first. So the first one, we have Kelvin. So let's look at the numbers they're given. You have 45 milliliters of helium at 300 Kelvin. So this is going to be our volume, and this is going to be our temperature. So this is a start, and it increases to a new temperature. So starting temperature, final temperature increases. So it starts low, ends high. So this is 1, this is 1, this is 2. What will be the new volume? New volume means going to be our V2. Okay, so let's write down our variables. V1 is 45 liters. T1 is 300 Kelvin. Our V2 is unknown, and our T2 is 350 Kelvin. All right, so we're going to plug into our equation here, V1 T2, V2 T1. We want to find V2, so we want to get this by itself. So we're going to move this to the other side. So we're going to move this to the other side. The T1 is going to come down here. We're going to divide by T1 to get this constant out. So our equations, V2 equals V1 T2 over T1, and then we solve for this. So our V2 is our V1, 45, times the T2, 350, over T1, 300. So 45 times 350 divided by 300. So we should get a 552.5 liters is our total. Okay, so that's the first one. Number 2, we want to change to Kelvin first. So our changing to Kelvin formula, the temperature in Kelvin is the temperature in Celsius plus 273. So Kelvin scale and Celsius scale are similar, except the Kelvin is 273 above the Celsius. So 0 Celsius is 273 Kelvin. All right, so let's go ahead and look at this one. We are given a couple different things. So we have a few different numbers. We know that this is our volume. So liters is volume. Temperature is in Celsius, so T. Our another volume, V. And here we have another T. So this is the start, 44.40 liters at 50 Celsius is the start, 1 and 1. What will be the new volume? This tells us it's the second part. New means V2 at 25 Celsius. All right, so we fill this in. V1 is 4.40 liters. T1 is our 50 Celsius. V2 we don't know. And T2 is 25 Celsius. So for us to solve this, we wanted to find Kelvin. We're going to add 273 to Celsius. So if we add 273 to both of these, this is going to give us Kelvin. So we'll get 298 Kelvin here, and then we're going to get 323 Kelvin here. So these are the numbers that we're using. We're not going to use Celsius, we're going to use Kelvin. All right, so let's put it into our equation. We have V1 T2 equals V2 T1. So to solve for this, we're going to put in our values. We're going to solve for V2. So we want to find this. So we're looking for V2. So we're going to divide both sides by T1. So this goes away. So we get V2, V1, T2 over T1. So we just plug in. V2 is our V1, so 4.40 times our T2, which is 298, over our T1, which is 323. So we solve for this. 4.4 times 298 divided by 323. So V2 is 4.06 liters. All right. Last one, we want to change this to Kelvin as well. Yeah, let's do this one. All right, so again, we have volume, temperature, temperature, volume. So volume, temperature, temperature, volume. This is our starting volume at -100. It's warmed to 100. So this is the starting temperature, -100, goes up to T2, +100. We have our volume, V1, is what we start with. The new volume, at a higher temperature. So this is temperature 2, the high temperature, volume 2, the high volume. All right, when we're solving for this, we're going to put into our variables. So V1 is liters. T1, we have -100 degrees Celsius. V2 is what we don't know. And T2 is going to be 100 degrees Celsius. So for this one here, we need to change this to Kelvin. So we're going to add 273. So this would give us, we subtract 100 from this, so we get 173 Kelvin. We add 100 to this, we get 373 Kelvin. And then we're solving for V2. So the setup for this is going to be the same as this one here. So V2 is V1 T2 over T1. So we put in V2 is V1 2.5 times T2 373 over T1 173. So 2.5 times 373 divided by 173 equals 5.39 liters. All right, nice. And then the last part's volume should decrease. As volume decreases, temperature should what? Which makes this a what relationship? Okay, so we can just kind of look at the first part here. We say that the relationship is direct, meaning if one goes up, the other goes up. One goes down, the other goes down. So this tells us if our volume goes up, our temperature is going to go up. This is what we call our Charles law. So if volume goes down, temperature should also decrease. We call this a direct relationship, meaning this is our Charles law.